Cambridge Assessment Admission Testing, 6th-term examination paper, STEP, 2019, Paper 1, Mathematics 1, Code number 9465, Section A. The link to the question paper is in the description below. Hi, I am Babak. In this video, I'm going to solve the fourth question in this past paper. Let us read the first part of the problem. Find integers m and n such that square root of 3 plus 2 square root of 2 equals m plus n square root of 2. Okay? Okay, I want to prove a lemma first, and then I will use this lemma to find m and m as demanded in the problem. Okay, so the lemma is this. Assume that I have a number of this form where is equal to number c plus d square root of 2, and I know that a, b, c, and d are integers. I want to prove that this happens if a is equal to c and b is equal to d. Yes. Okay, so the proof of this lemma. If a plus b square root of d square root of 2 is equal to c plus d square root of 2, I can move c to the left and I can move b square root of 2 to the right. So then it becomes a minus c. Then I will have d square root of 2 minus b square root of 2. Yes. And then I can factor a square root of 2 on the right hand side, then I will get d minus b is times square root of 2. Yes. So if I want to prove that b is equal to d, if b is not equal to d, then this means that d minus b is not equal to 0. So then it means that I can safely divide by d minus b, and I will get a minus c divided by d minus b is equal to square root of 2. But then what does it mean? Because a, c, d, and b are integers, this means that this should be a fraction. This is a rational number. This fraction is a rational number. So on the left hand side I have a rational number. On the right hand side I have a famous irrational number, square root of 2, and they cannot be equal. Yes. So it means that the assumption that b is not equal to d gives to a contradiction here. Yes. Gives rise to a contradiction. This cannot happen. So it means that therefore d is equal to b. Yes, as demanded, as I wanted to show. But if d is equal to b, then I have a plus b square root of 2 is equal to c plus d square root of 2, and then because b and d are equal, on the right hand side I can write c plus, instead of d square root of 2 I can write b square root of 2. And then if I move this term to the right, then they will cancel each other, and then I will get a is equal to c. Okay? Okay. Now let us go to start solving the first part of the problem. The first of the problem is actually telling us that the square root of 3 plus 2 square root of 2 is equal to m plus n square root of 2. I raise both sides to power 2, the left hand side becomes this, the right hand side becomes m plus n square root of 2 to the 2. And then I can use the quadratic pattern for the right hand side, which gives me m squared, the first one to the 2, 2 times the first one times the second one, and then finally the second one to the 2, which becomes 2n squared. Okay, but let me write it in this form. On the right hand side I can combine m squared plus 2n squared together, and I will have 2mn square root of 2. Now I can use my lemma. Yes. because it is mentioned in the problem that m and n are integers, so it means that this combination is an integer, this combination is also an integer, and then if you see, I can use lemma, the lemma that I proved here. So this implies that, so the lemma implies that I have a system of equations, m squared plus 2n squared should be equal to 3, and 2mn should be equal to 2. Yes. Okay, then I have to solve the system of equations and to find m and n. Okay, so here I can divide by 2m, because of course I know that m is not equal to 0, otherwise the left hand side becomes 0 and the right hand side is 2, so safely I can divide by 2m, so then n becomes 1 over m. Then I can plug it here. I will get m squared plus 2m over m squared is equal to 3. I multiply both sides by m squared, so it becomes m4, and then I bring this to the left, it becomes minus 3m squared plus 2 equals to 0. And then I can simply factorize this to m squared minus 1, m squared minus 2, yes, equals to 0. And then I get 4 answers. So m becomes either the first one is 0, which gives me m is equal plus or minus 1, or m is equal to plus or minus a square root of 2. Yes, but this is not acceptable since m is supposed to be an integer. So let me write it in this proper way. Since m belongs to z. Yes, so it means that these are the numbers that I can have for m. Okay, but then what happens for n if this happens? Since n is equal to 1 over m, so n becomes n is equal to 1 over m. This means that n is also plus and minus 1. But another point is that if you look here, if m is negative 1, n is also negative 1, then it means that the right hand side becomes negative. On the other hand, the left hand side is positive, so this cannot happen. So m equals to n equals to minus 1 is not acceptable. Yes. So then it means that the only number that we have is m equal to n equal to 1 is the only acceptable solution. Yes. So the only integers such that the only integers m and n such that this relation is satisfied is only m equals to n equals to 1. Yes? Okay. Now let us go to the next part of the problem, part 2. Let me read it for you first. Let f of x be equals to x to the 4 minus 10x squared plus 12x minus 2. Given that the equation f of x equal to 0 has 4 real roots, explain why f of x can be written in the following form. F of x equals to x squared plus sx plus p multiplied by x squared minus sx plus q. Okay, so we know that according to the problem, this equation has 4 real roots. Okay, so it means that it can be factorized to 4 linear terms. Okay, I just want to explain you. So here it means that f of x somehow can be factorized in the form of x minus a, x minus b, x minus c, and x minus d. And of course it becomes clear that, for example, if I combine these two, it gives me a quadratic expression, and this also gives me a quadratic expression. So f of x is the product of two quadratic expressions. Of course that is not a very important thing here, the important thing is that why we can write these quadratic terms in the form that this is Sx and this becomes negative Sx. Yes. And the reason to this is that if you are a little bit careful here, you see that in this polynomial, the third degree is absent. So the coefficient of x to the 3 in this fourth degree polynomial is 0. And this will imply that in this factorization, in this quadratic polynomials, this quadratic polynomial and that quadratic polynomial should be in a way that the linear term, the coefficients of x from this quadratic one and the coefficient of x from this one should be opposite to each other. Okay, how we can prove that? Okay, so let me think in this way. So I would say that let f of x be decomposed into two quadratic forms. So let us call it, I don't know, let us call one of them s, and let me call the other one s prime. Yes. What I know is that the coefficient of x3 should be 0. But if I want to calculate the coefficient of x3, what is the x3 term coming from? The x3 term comes from multiplying x squared by s prime of x. It gives me an x to the power of 3. Another x to the power of 3 comes from the multiplication of this term by that term. I will not be able to get x to the power of 3 in any other ways. Okay, so it means that the coefficient of x3 in this expansion is, okay, what is that? So let me multiply here. So I will get sx times x squared plus I will get x squared times s prime x. So it means that I have sx3 plus s prime x3. So it means that I have s plus s prime x3. So the coefficient is s plus s prime. This is on the one hand. On the other hand, when I go back and look at my f of x, I see that I have x to the 4 and then suddenly I have x to the 2. So it means that the coefficient of x to the power of 3 is indeed 0. So it means that s plus s prime has to be equal to 0. Yes. So then it means that s plus s prime is 0. So it means that s prime is negative s. Okay. So this means that this s prime is just negative s. So then I will get exactly the form that I have been given. Yes, okay. So what I learned is that I can write f of x in that particular form. And now we are supposed to find, let me read it for you now, for some real can be written in the form of f of x equal to that, then for some real constants s, p, and q, and find 3 equations for s, p, and q. Okay, so we are supposed to find 3 equations for s, p, and q. Okay, of course I need to expand this and equate it with that one, make them identical. Okay, so how can I expand them? So I have x squared plus sx plus p. I multiply this by x squared minus sx plus q. Okay, I use this fact that this is the common term. So x squared times x squared gives me x to the 4. Then what I have, I need to add these two terms and then multiply it by the common term x squared. Yes, so I'm actually using this identity. So if I have something in my box plus something in the circle, and if I have the box multiplied by box plus the triangle, what I see, if this is the common term, I can write the common term to the 2, and then I can add these two terms and then multiply it by the common term, and finally I can multiply these two at the end. Yes, so I want to use the same thing here. I'm just assuming that this is my box here, and this is my circle, and this is my triangle. Okay, so then it becomes the box to the 2, which gives me x to the 4, and then I need to add these two terms together and multiply it by the common term. But when I add these two terms, sx and minus sx are gone, so I am left with p plus q, so it becomes p plus q, and I have to multiply it by x squared. And finally, what I have to do is to multiply this term and that term. Here I can factor a minus sign out, so it becomes minus sx plus p sx minus q. Yes, and then I can factor it again, so I can use this identity once more, so this becomes p plus q x squared, and then here you see now this will play the role of the box, and this play the role of the circle, and this is the triangle. So I can use this identity once more. Of course, it doesn't matter. You can just go multiply them term by term and then combine them at the end. Okay, that's up to you. So then it becomes minus s squared x squared. Then I will have plus q minus p sx, and then finally I will have p times q. Okay, so what I get is this expansion. So it's equal to x to the 4, and then I have p plus q minus s squared x. I factored actually x squared out, and then I will have plus q minus p sx, and then I will have pq. So this is my final expansion here, and then I want this one to be identical to the given function. So x4 is already here, but this coefficient, this is the coefficient of x squared, it should match with the coefficient of x squared here, which is negative 10. Yes, so then it implies that I have these equations. So let me write it as a system. I have p plus q minus s squared is equal to minus 10. And then I have q minus p times x is 12. Here, this is the coefficient of x, and the coefficient of x is 12. And then pq should match with minus 2. Yes, so I will get pq is negative 2. So these are the three equations for s, p, and q, which is demanded by the problem. And then I am supposed to show that this relation holds for s. So it means that in this system of equations, I need to find a relation independent of p and q. Yes, because this relation that I am going to prove is only involved with s. So I need to get rid of p and q in some way. Okay, so this s2 minus 10 will give me some kind of hint. If you look here, I can move s2 to the right hand side, then I will have at least that combination s2 minus 10. Okay, so let us do that. So this means that p plus q is equal to s2 minus 10. And then if you see, I have a power of 2 for that, so it motivates me to raise both sides to power 2. So this becomes p plus q to the 2 is s squared minus 10 to the 2. Okay. Okay, and then if I expand this, this becomes p squared plus q squared plus 2 times p times q is equal to s squared minus 10 to the 2. Yes, but now you see that pq is given to be minus 2, so if I put minus 2 here, it becomes minus 4. Yes, so then it becomes p squared plus q squared minus 4 is equal to s squared minus 10 to the 2. Okay. Okay, so I need to get rid of that, so then it becomes easy. Hopefully you can guess. Here I divide by s, so q minus p is equal to 12 over s. Yes. of course you know that s cannot be equal to 0. Why? Because if s is equal to 0, then this is you see, if s is equal to 0, the left hand side is 0, the right hand side is 12. So s is not equal to 0, so I can safely divide by s. And then I raise both sides to power 2. The left hand side is a quadratic rule again, so it becomes the first one to the 2 plus the second one to the 2 minus 2 times the first one times the second one, and on the right hand side I will get 144 divided by s squared. And again, you see that PQ is minus 2, so I can put minus 2 here. What I get is P squared plus Q squared plus 4 is equal to 144 divided by s squared. Yes. So this means that P squared plus Q squared that I am looking for is 144 over s squared minus 4. Yes. And then finally I am actually done, because I can take this one with me and put it here. Then P and Q are totally gone, and I will get an expression involved only with s. So if I put that here, then it becomes 144 s squared minus 4. So I replace this expression instead of this, but I have an extra minus 4 here. Minus 4 is equal to s squared minus 10 to the 2. Yes. And then minus 4 is minus 8. Yes. And the right hand side I have s squared minus 10 to the 2. Okay, now look back at the relation that you want to prove. You have s squared and everything is more or less clear, so I multiply everything by s squared. I multiply everything by s squared. The left hand side becomes 144 minus 8s squared, and the right hand side I will have s squared times s squared minus 10 to the 2. Okay, I move everything now to the right, so it becomes s squared minus 10 to the 2 plus 8s squared minus 144 equals to 0. And that is exactly the relation that I was supposed to show. Okay. And now we're supposed to find 3 possible values for s squared. Okay, so suppose I want to find s squared, so let me give it a name. So I would say let s squared be denoted, for example, by, I don't know, capital T. Then this equation reads that it becomes t minus 10 to the 2 plus 8t minus 144 equals to 0. So I'm supposed to solve this equation. Okay. Okay, I don't. One way of solving this probably is to just expand this. So this becomes the first one to the 2 minus 2 times the first one times the second one plus the second one to the 2, and then I have plus 8t minus 144 equals to 0. And if I expand that, it becomes t to the 3, and then I will have minus t 22t squared, and then I will have 100t plus 8t is 108t, and then I have minus 144 equals to 0. Usually for the third degree polynomial equations, you need to check the integers, check the factors of this for the solution. Okay, it's clear that minus 1 and 1 doesn't fit the problem, but let me check 2. So if my guess is t2, so if I put 2 here, this becomes 8 to the 3 minus 20 times 2 to the 2 plus 108 times 2 minus 144. Let us see if this is equal to 0. Sorry, this is not 8 to power 3, I made a mistake. I'm supposed to put 2 to the 3, which becomes 8, and then this becomes 80, this becomes 260, and this becomes minus 144. Is that equal to 0? It's minus 72, Yes, so that's equal to 0, that's correct. So it means that t equal to 2 is a solution of this equation. And then since we are supposed to find all possible values, I use the long division method to find the other solutions. So I would write t cubed minus 20t squared plus 108t minus 144, and I divide this by t minus 2, since I know that this would be divisible by t minus 2. So let me change the color to confuse here. So t3 divided by t, it becomes t squared, so I multiply it here and then subtract them, so it becomes minus 18t squared plus 108t minus 144. And then I do the division once more, so it becomes minus 18t, so it becomes minus 18t squared plus 36t. And if I do subtraction, this is gone and this becomes 72t minus 144. And then I divide once more, so it becomes 72. It becomes 72t minus 144. So as I guessed, the remainder is 0. So this will help me to factorize this expression. So therefore, this implies that t to the 3 minus 20t squared plus 108t minus 144 is equal to t minus 2 multiplied by t squared minus 18t plus 72. Yes, and then of course this is easy to factorize this quadratic polynomial here. It's t minus 6, t minus 12. Yes, because if you multiply these two together, minus 6 and minus 12 becomes minus 18, and the product is exactly positive 72. Okay, so I am supposed to solve this equation equal to 0. So if I put this equal to 0, putting this equal to 0 means that this is equal to 0, and by the zero product rule that it is t is either 2 or 6 or 12. Yes, but t was another name for s squared, so this means that s squared is 2 or 6 or 12. So these are the three values. Sorry, let me write over here. 6 or 12. Okay, so these are the three possible values that was demanded here in this problem. And now the last part is that use the smallest of these values of s squared to solve completely the equation f of x equals to 0, and simplify your answers as far as you can. Okay? Okay, so let me choose s squared. The smallest one is s squared equal to 2. Yes. Okay, so let me go to the next page. If s squared is 2, so this means that s is plus or minus the square root. By the way, let me copy paste these equations that I need here. So let me bring these equations with me to the next page. Hopefully I can copy it correctly. So yeah, let me clean this one. Copy, yeah, paste it here. Yes, good. And of course I don't need this arrow here. Okay, now s squared is given to be 2. Of course, in principle I can get s equals to plus or minus the square root of 2. Okay, but here s squared is 2, so I can put it here. Then it means that I have p squared plus, I have p plus q minus 2 is equal to minus 10, so I get p plus q is equal to minus 8. And we already know that p plus q, p times q is negative 2, so I can solve a new system. p plus q is -8 and pq is -2. For example, here you can find q, it's -8 minus p, and you plug it here in this equation. This implies that I have p -8 minus p is equal to -2. So then it means that you have p squared plus 8p minus 2 equals to 0. Okay, and I will solve this for you. So this p becomes equal to -8 plus or minus square root of 64, and then I will have plus 8 divided by 2. Yes, so then it becomes -8 plus and minus, this is 72, but 72 can be written as 9 times 8, so it becomes 3. No, I can write it as 72 can be written as 2 times 36, so it becomes 6 square root of 2 and divided by 2, and it becomes -4 plus or minus 3 square root of 2. So it means that I have two values for p. One of them is -4 plus square root of 2, and the other one is -4 minus 3 square root of 2. Yes, but now if I plug this value here, I can find q, but this means that q is equal to -8 minus this number, so it becomes -8 plus 4 minus a square root of 3, which becomes -4 minus a square root of 3, which is the other value for p. So it becomes clear that q in this case would be equal to the other value, -4 plus 3 square root of 2. Okay, but now this relation is important here. Okay, so it doesn't matter, because as far as you respect these equations, then it means that this becomes equal to that. But we have different options available here. But then we have to respect which ones to choose. The middle equation is crucial here. So you see that because this 12 is positive, so it means that the product of s and q minus p is positive. So it means that the sign of s and the sign of q minus p should be the same. Either both of them should be positive or both of them should be negative. Yes. So for example, let us choose s equal to the positive value square root of 2. Yes, I would choose s equals to that. So because now I have chosen a positive value for s, I have to respect that q minus p should be positive, so q should be greater than p. Okay, if I choose this first one, q is smaller than p, so that is not acceptable. I have to choose this one. Yes, so if I choose s equal to square root of 2, then p has to be -4 minus 3 square root of 2, and q has to be equal to that one. Yes. Okay, now I have everything ready. So my goal is to solve f of x equal to 0. Now we realize that s is this, p is this, and q is this. I put them here in this equation and then put it equal to 0, and then I have two quadratic equations that I can easily solve. Okay, so let me do that. Okay, so if I use this relation here, I would use this relation here, then f of x becomes equal to x squared plus square root of 2 times x plus p, which is -4 minus 3 square root of 3, and then x squared minus square root of 2x minus 4 plus 3 square root of 2. Yes, so now f of x equals to 0 gives me that either this one is 0 or the other one is 0. So I made some mistake here, yes, because this is not 3, this is 2. And this is not 3, this is 2. Okay, so now let us concentrate here. So let me call this one number 1, call this one number 2. Yes, now I am interested in number 1. So x becomes equal to minus the square root of 2. I am using the quadratic formula, plus and minus the square root of 2 minus 4 times minus 4 minus 3 square root of 2, and then I have divided by 2. Yes? This becomes minus the square root of 2 plus and minus the square root of. So minus 4 times minus 4 is positive 16, and positive 2 becomes positive 18. And then minus 4 times minus 3 is positive 12 square root of 3, and then I have divided by 2. And then you can immediately see that I can write it in that way. I can factor a 6 out from these two, so this becomes 6. Then I will have 3 plus 2 square root of 2, and then I have divided by 2. But then I can write it as minus the square root of 2 plus and minus the square root of 6 multiplied by square root of 3 plus 2 square root of 2. The reason that I am doing here, I'm continuing, is that because it has mentioned that simplify your answer as far as you can, and traditionally you know that in step exams usually the first part will be helpful for the other parts. So and that is the reason that probably they have mentioned that part in the first place, and you see that's not a coincidence. 3 plus 2 square root of 2 is actually exactly this one. And if you remember, let me go back. Here we were able to find that m is equal to m is equal to n. So this means that this expression is 1 plus the square root of 2. Yes? By the way, I realized that I could do it much simpler here now. So I will go back and tell you how can I do it simpler. But anyway, here m and n are equal to 1. So this means that I can continue and write this as minus a square root of 2 plus and minus a square root of 6. And instead of this expression, I can put 1 plus square root of 2, and then I will have 2 in the denominator. So this means that I will get 2 solutions from here. So it's minus 2, positive square root of 6, positive square root of 12, which becomes 2 square root of 3 divided by 2, or I have another answer which is minus square root of 2 minus square root of 6 and minus 2 square root of 3 divided by 2. Yes. And then let us do number 2 here. So number 2 is also the same, so the similar. So x becomes square root of 2, and then I have plus and minus square root of this 1 to the 2 is 2, minus 4 times minus 4 plus 3 square root of 2, and then I have divided by 2. So if I calculated this, it becomes again 18, but this time it becomes minus 12 square root of 2, okay, and then I have divided by 2. Yes, let me make sure that everything is in order. Yes. And then I can factor it out exactly as before, so it becomes square root of 6, and then I will have square root of 3 minus 2 square root of 2 divided by 2. Yes, so now let me describe you the second method that I could in principle solve the first problem easier. Yes, so now let me describe it here for you. The only difference is that here I have a negative sign. Okay, it's not that important, so let me just do that. So if I can write as 3 minus 2 square root of 2, I can write, instead of 3, I can put square root of 2 to the 2, minus 2 square root of 2 and then plus 1 to the 2. Let us check. Square root of 2 to the 2 becomes 2, 1 to the 2 becomes 1, 1 and 2 becomes 3, and this is exactly the same thing. So this is the quadratic pattern, so it becomes square root of 2 minus 1 to the power of 2, so it becomes absolute value of the square root of minus 2 minus 1, but the square root of 2 minus 1 is positive, so it becomes the square root of 2 minus 1. So if you don't mind, let me take this one with me to the other page, and remember that this square root part, is this one. Okay. Okay, so I will take this one with me. Copy. So we go to the next page here. So let me continue now here. So it becomes a square root of 2 plus and minus a square root of 6, and if you remember, it was a square root of 2 minus 1 divided by 2. So then again I have two answers, so it's square root of 2 plus square root of 12, which is 2 square root of 3, and then I have minus a square root of 6 divided by 2, and then I have a square root of 2 minus 2 square root of 3 plus a square root of 6 divided by 2. Yes. So if I go back and copy the solutions from the first one, then we can have all of them next to each other. Yes. Copy. So I go here and paste it here. So these are the 4 values for x that I was looking for. The problem was actually demanding. Yes. So 1, 2, and 3, and 4. Yes. Okay. Thank you for watching the video. I will continue to solve this set of problems until we finish all the papers, hopefully. Yes. Thank you for watching the video, and I really appreciate if you have any comments, suggestions. If some of the problems you want to be solved first, you can just leave me a comment. I will try to make a video and solve that problem for you first. Okay? Thank you for watching, and goodbye.